Okay, as I was saying before I quit, let's try this again. Last part of this unit deals more with the algebra than with the proof type stuff. We are still going to be doing proofs, but we're going to be doing them algebraically, which means using distance formula, midpoint formula, slope, that sort of thing, yes. Well, we go A, B, C, D, E, F, G, H, I, J, K. I think L or M is our last one. D. We get through F first quarter, and then we just keep going. And the reason we do it by unit letters is because we don't necessarily, you've noticed, follow along just with the chapters in the books. We kind of reordered it and rearranged it a little bit. And sometimes we mix things in from multiple chapters. So that's why we redid that. But it's still, I think, about 12 or 13 at the most units. 6 per semester, I can tell you that for sure. We get through F. Classifying triangles. So we're going to learn some basic stuff about triangles. We're going to go back to the setting up and solving equations deal, using triangles and facts about triangles. We do have to be able to classify triangles, and you may think this is ridiculously simple at this point. The ideas of, gosh, what's an equilateral, what's an acute, what's an isosceles? What do those different things mean? But really, people struggle with this. People do struggle on the quizzes and tests because I will draw pictures of triangles on the chapter, on the quiz and the unit test, and say classify the triangle according to angles and sides, and people will not know the names of triangles. They will not know the difference between scalene and isosceles. So this is something you're going to have to think about a little bit. We can classify by the lengths of the sides. Every triangle will have at least 2 names. One special triangle will have 4 names, but everything else has at least 2. One that names it by its sides, one that names it by its angles. So for sides, it can be scalene, no 2 sides congruent, all the sides are different. Isosceles, meaning at least 2 sides are congruent. Or equilateral, which means all 3 sides are congruent. Now, an equilateral triangle is also isosceles because it has 2 sides, at least 2 sides congruent. So actually equilaterals are also isosceles, but not all isosceles are equilateral. We can also classify by angles. We can have acute triangles, right triangles, obtuse triangles, and equiangular. When we classify a triangle by its angles, we always classify by the largest angle. Because even in an obtuse triangle, two of the angles are acute, aren't they? In the acute triangle. Let's make sure our phones are put away. Not just, I know, but I want it put away so it doesn't become a distraction if somebody messes with you. Okay? Let's get them off the desks entirely for now. So you always classify by the largest angle of the triangle. The only difference is, of course, equiangular. Equiangular, all 3 angles are 60 degrees. Equiangular triangles are also acute. They get the extra name. As a matter of fact, the only triangle that gets more than 2 names is this one. Right? Whoops. This one right here, which is the same as this one. It is equilateral, equiangular, isosceles, and acute. We get that one triangle. That is the only triangle that gets 4 names. Everything else just gets 2. But that triangle's special. It gets 4 names. Yep. It's just special. So we can classify triangles. We can name them. It's a pretty simple process. But again, we need to know what those names are. Notice the marks on here showing things are right angles or stuff like that. I will put a right angle mark in here. And yeah, that's it. So how would I classify this first triangle here? The black triangle. What do you say, Owen? It is a right triangle. That's the name for its angles. What would be a name for its sides? Isosceles. So we call this right isosceles. How about this one? And I'll tell you that. It's true. Obtuse, isosceles. What if I called isosceles obtuse? That'd be fine. Okay. This angle is 100 degrees, let's say. So how would I name that triangle? Obtuse. And no two sides are indicated to be congruent, so it would be equilateral. Scaling. Okay. This one, no two sides are the same. The largest angle is, say, 79 degrees. That's the largest angle. So this would be acute and scalene. And this, of course, all three sides the same, is our very special case. It's acute, isosceles, equilateral, and equiangular. Yes. Just for that one triangle. That's the only one that gets all four names. Any other triangle will just have two names. That's the only one. The only one. Because we want to give all names that accurately describe the triangle. And that's kind of what we're after here, is describing the triangle. Triangle sums. We do need to talk about triangle sums. We have interior angle and exterior angles when it comes to triangles. Now, most of you know this already. The interior angles of a triangle add up to how many degrees? 180. I think that's something you learned, what, back in 6th grade or something like that? If you add up the three interior angles of the triangle, you get 180? Yeah, that's pretty old. Most of you know that one off the top of your head. What's different here is now we're going to talk about exterior angles of a triangle. We add up the three exterior angles. Start off with, to make an exterior angle, I have to extend a side and make the exterior angle. And the three exterior angles add up to not 180, but 360. But what's even more interesting is this little tidbit. I know that an exterior angle plus its corresponding interior angle, those two make what kind of angle pair? What do we call that angle pair? Linear pair, which means they add up to 180. So if I call the measure of this angle A, this measure of angle B, and this measure of angle C, not B, I already put B down. Okay? A plus B plus C, the three interior angles add up to what? What's their sum? 180. Let's call this exterior angle D. We just said that A plus D also equals 180, doesn't it? Because it's a linear pair. So that means A plus B plus C equals A plus D. Right? So they both equal 180. If I subtract A from each side, I get B plus C equals D.
Oh, okay.
So that's kind of interesting that in a triangle, these are what we call remote interior angles to this exterior angle. All right? Yeah, that's going to get 4 because I want to have different marks. Okay, if this is the exterior, then these two are the remote interiors. If this is exterior, then these two are the remote interiors. But the measure of the exterior always is a sum of the remote interiors. Remote meaning distant. Not the adjacent interior, but the two remotes. These two angles always have to equal the measure of that angle. Or this angle has to equal the sum of those two. Or this angle down here has to equal the sum of these two. It has to, because of the 180 something we just did there. It always works out that way. And that's kind of interesting. Let's see if this opens up. Now, Proving why a triangle sum is 180 is kind of interesting. And the reason is this. What I've done is I've created the triangle here in red. And we've got parallel lines, okay? OE and AB are parallel lines. Now, if I measure some angles here, hold on. I measure the angle. The measure of angle ABC is 48.2 degrees. The measure of BCE is also 48.2 degrees. Why is that true? What is true? What kind of angle pair do we have there with these two angles? What do we call that? Those are alternate interior angles, aren't they? And they have to be congruent. And we could do the same thing over here. Okay, there's CAB. What would be alternate interior CAB? Well, it would be ACD. And finally, we have our third angle up here, AE. It just crashed. Okay. We can still finish what we're doing here. AB, ACB. Measure this angle. This is essentially the proof of the triangle sum theorem. Because what we're saying is that since these three angles together have to add up to 180, because they make a straight line here when they put them all together, right? These two angles are congruent, and these two angles are congruent. Therefore, the sum of that's why the interior sum has to be 180. That's the proof of why the angles of a triangle add up to 180. I think it doesn't matter where the angle is, or if it's an obtuse triangle or an acute triangle, okay? I can make it be way out here. The angles are still the same angles. They've changed measurement. But the sum of these three is still 180, and the sum of the three interiors is still 180. So it doesn't matter if I have obtuse, acute, or otherwise triangles. That's what we get. We're doing triangle sum. See what it rescued. But that is our triangle sum theorem that we're dealing with. Oh, it looks like it saved most of it. Whoops. Good. All right. Exterior angle theorem, we already did this one. That the sum of the exterior is the sum of the remote interiors. We've already done that. This is a corollary to a theorem which is kind of interesting. I've got a right triangle here. And it's not indicated, but that's okay. What must be the sum of A and B? If that's a right triangle, then A and B together have to add up to what? Well, let's think about this. If I take AB and this angle down here, what's the total going to be? 180. How many degrees am I using up for this angle? 90. So how much is left for these two? 90. That's one of our little theorems. It says the two acute angles of a right triangle have to add up to 90. Okay? The two acute angles have to add up to 90. And one of the homeworks we're going to deal with today is going to be simply like this. We're going to give you, say, this is 90, this is 23 degrees, find x. Okay? That's a real simple level problem. Add them up and get to 180. No problem. A little more complicated problem. Let's say this angle is 85 degrees. This is x. This is x plus 30. Okay, so x plus 30, no, plus 85 equals 180. There we go. Got to put all three angles together to get to 180, right? So 2x plus 115 is 180. We got to do the algebra.
Minus 115 and then divide by 2.
So 2x is 65, so x is 32.5. Okay? And so it's 32.5 and 62.5 for the angles. Can't wait?
How do you get the 45?
Really? Because we're like in the middle of stuff. You sure can't wait? Okay. I'm sure your phone stays here. That's good. Be safe. Just wrong. All right, how about this one? 5x plus 2x plus 3x. What's that going to have to equal? All right. So 10x equals 180. So x equals 18. Now, we could find the measures of each of the angles now by substituting that back in, couldn't we? This would have to be 36. 3 times 18 is 54. 5 times 18 is 90. And look at that, we've got that all figured out. Careful. They don't. They aren't. 6x is not inside the triangle, is it? It's way different.
I wasn't talking about that one.
Oh. Yeah, these three add up to 180. I thought you meant over here. Okay. Sorry, I thought you were jumping ahead. My bad. All right. What's going on here? Some angles are being shown, but how are we going to set up an equation with this information? Yeah. The linear pair. Yeah. We don't even need this down here. This is not something that we need to solve the equation, is it? So we just need these two. 6x plus x plus 10 is 180. So 7x plus 10 is 180. So 7x is 170. So x is 170 over 7, and we could get that. Well, let's see, then they said find all the angles of the triangle. Now I'd have to substitute. Now, it didn't come out nicely, so I'm not going to actually do that. But we'd have to take this value, substitute it in here, substitute it in here. Once I know those two angles, I could find that third angle, couldn't I? 1714. Well, 170 divided by 7, that's not going to reduce. So, yeah, the numbers came out kind of messy. But for this one, it just said find the value of x. There's just extra information. And you need to know what to pick out. It's not a trick. It requires you to be perceptive. Okay, and I think that's it. That's what we're doing today. I mean, this is not the difficult stuff yet, but you do need to make sure that you are solid with this information. This is stuff you have. Most of what we're doing here should be reviewed for you. No, I think it's in your book today. You may certainly go ahead and do so, yes.
Why can't you?
Because I already posted it here. I don't need to print it out.
Is there anything else you changed that I should know about?
Do you have any,
Not today.
do you have any pictures of or anything?
We are still on schedule for a benchmark this Friday.
Today Monday?
Today is Monday. Monday, November 11th, Veterans Day.
Yep.
Veterans Day?
Yeah, today
Yes.
was Marie's birthday.
Nope. So. All right, so there we are. There's your assignment.
There we are. Okay.
Mr. Dorn, do you have any super glue?